Hey guys, I just want to let you know you're going to hear the bell ring in a minute because this is a passing period, so I just wanted to give you a heads up. So I just feel like I want to post this video so you have another resource to help you with limiting reactant, because honestly it's just not enough time that we had together when we were learning it, and so this is if you need more support. Okay, everyone should be watching this video. It is linked to its learning for Monday and Tuesday when I'm out with the sub. So limiting reactant, guys, is a reactant in a chemical reaction that runs out first. Okay, so it limits how much product you can make. Okay, it's the reactant that runs out first. Okay, so a long time ago, actually not a long time ago, pretty recently in the past, in the curriculum, you guys would have had to do 2 stoichiometry problems to figure out which one is your limiting reactant. We no longer have to do that. Okay, but what you do have to do is identify from a particle diagram which reactant is going to run out first. There's the bell. Okay, so we haven't done particle diagrams in a really long time, since Unit 2. Okay, so that is honestly probably what you're struggling with more than anything if you're struggling with limiting reactant. So let's get some practice in just drawing some particle diagrams before we even address which of those reactants would be your limiting reactant. So let's draw 2 moles of zinc. Okay, zinc is just a single atom. It's not zinc 2, right? It's just zinc. So you've got 2 moles of them, so there's 1 mole of zinc and 1 mole of zinc. Okay, now let's draw 3 moles of O2. O2 is 2 oxygens joined together. Okay, it's a molecule, so let's draw it like this. And I have 3 of them. Got it? So 3 moles of O2. This one, let's draw 1 mole of aluminum chloride. Okay, so I'm only drawing 1 of these compounds, and in the compound I have an aluminum and 3 chlorides. Okay, now later on I'm going to be color coding those so you can identify what is what in your products, but this is just what a particle diagram looks like. Hopefully this is kind of all coming back to you from Unit 2 when we were drawing these when we did matter. Okay, now we need to do this so we can identify which reactant is running out first. Okay, which reactant do you not have enough of to keep forming products? So let's practice drawing some particle diagrams for chemical reaction. Let's balance these. This one I just already know is this, your coefficients. So I have 2 moles of H2. So H2 would look something like this, and I'm going to color code them so we can see us form the H2Os. And I have 2 moles of that. So I'm going to draw 1 more mole. Okay, now oxygen is O2. Okay, so it's 2 oxygens combined, and I have 1 of them. And then those together form 2 moles of water. Okay, so in a water I have 2 hydrogens and 1 oxygen. Okay, so do you see here that I have used 2 hydrogens and 1 of my oxygens to form 1 water? And I can make 2 moles of water. Okay, so there I have used my other H2 and my other oxygen. Okay, so you see that this equation is balanced when you draw it in a particle diagram, because you can see you have 2 moles of H2 over here, and they're still there in your products. You had 1 mole of O2 over here, and it's still here in your product. It just got split up. Okay, So take a second, pause the video, and try to draw the particle diagram for the following reaction. Go ahead and get it balanced first, and you're lucky because it's already balanced. So pause the video here. I'm going to continue doing the particle diagram, and then you can check your work. So I have 1 mole of iron. Okay, I'm going to draw it like this, a big yellow circle, one of them. And 1 mole of zinc oxide. Okay, so I'm going to draw oxygen purple, and zinc I'm just going to leave as a white atom. Okay, 1 of them. So in my products, they rearrange partners, but you don't lose or gain matter, so I'm still going to have 1 zinc and 1 iron oxide. Iron was yellow and oxygen was purple. Okay, so you can see I still have my zinc, I still have my oxygen, and I still have my iron, but they all rearranged partners. Okay, so those are particle diagrams. They're already balanced. We don't have a limiting reactant because it's a balanced chemical reaction. It works out perfectly. Okay, but sometimes you're going to have more than what you should have in your balanced reaction. So let's look at this right here. Carbon plus sulfur produces carbon disulfide. Okay, before the reaction, so your reactants, okay, you have how many carbons? 1, 2, 3, 4, 5, 6 carbons. Okay, so I'm going to go ahead and fill these in because I know I'm going to have to answer these later. And 1, 2, 3, 4 sulfurs. Okay, so I need to make as many carbon disulfides as I can. Okay, so for each carbon disulfide, I need 1 carbon. So there's 1 carbon that I used up, and 2 sulfurs. So there's 2 sulfurs that I used up. Okay, to make another one, I've still got plenty more to make. So I'm going to use another carbon and 2 more sulfurs. You don't have to be going through and color coding this, guys, but you can. So there's 2 more sulfurs. Okay, so I've now used all of my sulfurs. I only made 2 moles of CS2. But I have all these extra carbons left. Okay, so which reactant did I run out of first? Which one am I completely out of and I have to stop my reaction? Just think about that for a second. So in conclusion, which reactant, carbon or sulfur, is in excess? Which one is left over? Which one could still form some more molecules? That would be carbon. Okay, because look, you had more left over. It's still over here waiting for more sulfurs. Which reactant limits the reaction? Which one is used up first? It's your sulfur, right? You used them all in the 2 moles of CS2 that you have, and you're out. Okay, so your limiting reaction, your limiting reactant, sorry, that's going to be annoying if I don't put that there. These are your products. Your limiting reactant is the sulfur. Sulfur is the limiting reactant. And carbon is called the excess reactant. Okay, so that's awesome if you understand this. Okay, but what you're going to have to do on your quiz on Wednesday and on the test when you take it on the 9 weeks test, you're going to have to figure that out on your own. You're not going to be given those particle diagrams. Okay, so let's do one together, and then I'll have you pause the video and do this one. And then the key to this, of course, will be online. So this one says, draw the particle diagram for the reaction in the space provided. Okay, so just draw it. Don't worry about balancing. Just draw KCl. So K, I'm going to do purple. My CLs, I'm going to do, oh, why did I do 2? I am crazy. And then my O2, I'm just going to draw as a white circle. So KCl plus O2. Okay, and then my product, I'm going to do in a second. This tells me I have 5 moles of KCl and 5 moles of O2. So I need to draw 5 of each of those. 2, 3, 4, 5. And I said I'm going to do potassium as purple and chlorine as yellow. And oxygen I'm leaving blank. So there's my 5 moles of KCl, and I need 5 moles of oxygen. Okay, now it says to create as many moles of KClO3 as you can with these reactants. Okay, so for every KClO3, I'm going to need 1 potassium, 1 chlorine, and 3 oxygens. You can draw it however you want. You don't have to draw it in that shape. So there's my potassium, there's my chlorine, and there's my 3 oxygens. So I need to keep track of what I'm using. I've used a potassium, I've used a chlorine, and I've used 3 oxygens. Okay, so keep going until you run out. Okay, so on this next one, I'm going to use a potassium, a chlorine, and 3 oxygens. Okay, so I've still got more of each, so I can keep going. On this next one, I'm going to use a potassium and a chlorine and 3 oxygens. Okay, so now I've got plenty of potassiums and chlorines left, but I only have 1 more oxygen left, and I need 3 for this compound. So I cannot make any more potassium chlorates. Like, you are out. So which reactant did we run out of first? We have a ton of potassium chlorides left, but I'm out of oxygens. Okay, so this is called the limiting reactant. Okay, oxygen is your limiting reactant. I'm going to say LR. And potassium chloride would be called your excess reactant. Okay, so this video is getting kind of long, guys, so I'm going to go ahead and stop it. You need to try the next 2 on your own. The key is on its learning, okay, so you need to get on and find the key to the stoichiometry part 2 notes and check your work. Okay, there's some more of these on the review that you're working on in class as well, so you can check those once you practice them.